new models being released regularly, do you ever wonder what goes into the making of these LLM? What makes these models so powerful? Hello everyone, this is Antara Raman Sahay, and today we will be deep diving into the secret sauce behind making these LLMs. We will be asking what refinement does each new model makes and discussing about one of the most common practice used in all language model, inclusion of code data. Including of code data in the pre-training data mixture, even for the models not specifically designed for code, has become a very common practice. For example, all the state-of-the-art model such as Palm, Gopher, Bloom, which are not intended to support code generation, includes a percentage of code data together. For instance, Llama 3 has more code data as compared to your Llama 2, which brings to a question: to code or not to code? So, to analyze the impact of code, this paper conducts extensive evaluations and evaluates the language models along different benchmarks, namely your natural needs, natural language reasoning task, world knowledge task, and code generation. Before moving ahead, I want to give you a concise information about the phases of training LLM. So, it all starts with pre-training phase. In this phase, model learns the language structure, its semantics from the vast text data. This results in the broad understanding of our natural language. Then the second step is the fine-tuning phase. So here the model adapts for a specific task. This helps in specialized task performance. Third is our continual pre-training. So in this, new or updated knowledge is added without losing the previous knowledge which we added in our pre-training phase. Then we have the fourth stage, which is the cool down phase. So during cool down, model's learning rate is gradually reduced and high quality data set has given more priority. Last, we have the evaluation and fine tuning phase. So the best analogy to relate to all this would be the phases of learning in our own human learning. The lifelong earned lessons from our parents, the school life, is the pre-training and the fine-tuning, the building block of our learning journey. College is continual pre-training, new knowledge is added or updated, but the previous knowledge which we have learned from our parents and school is not lost. What we further continue in our profession is the cool down phase. Here the learning rate is gradually reduced if we compare to our school life, and high quality data set, that is our specialization, is given much more preference. Lastly, we always fine tune and evaluate our learning based on our experiences. So the overview of this experimental framework is we evaluate the impact of code by evaluating code proportions, state at which the code has been introduced, code quality and property, and the model scale. So in this experiment setup, pre-training is considered into two phases. One is the continued pre-training and the second is the cool down phase. Here, continued pre-training refers to a model which is initialized from a pre-trained model and trained for a specific token budget. So the first is your impact of initializing using code pre-trained models. To understand this better, imagine 4 robots whose trainers have trained them on different ways. First is your text language model who has been trained on text only data. Second, we have balanced language model. So here his trainer has trained him on equal ratio of code and text data. Third, we have balanced initialized text. So this robot has been trained on equal ratio of code and text data and continually pre-trained on text data. Then we have code initialized text. So what happens is here it is only trained on code data and continually being pre-trained on our text data. Let's see what happens. So during exam time for natural reasoning, code text has the best performance, followed by your balanced text. For knowledge, world knowledge task, balanced text has the best performance, and for a code generation, balanced only robot has the best performance. Then we have impact of scale. So we are considering two, which is 470 million and 2.8 billion robot. Continuing with our robot analogy, turns out bigger robots did much better at everything. Then we have code data proportion in pre-training. So here we train 6 models for 200 billion token with increasing code proportion such as 0%, 25%, 50%, 75%, 90%, and 100%. And the remaining proportion is filled with the text data. So for natural reasoning, as the code increases, the performance also increases. The best performance is from 25% code data and 75% text data. World knowledge, we see an inverse relationship. With increasing amount of code data, this is reduced. For code generation, best is no code model. So for the code generation, linear increase in performance as the amount of code increases. So we get the best is the best code model. Then we have code quality and code property. Now we have been judging with different proportion of code and text data with their different combination. But what about the type of code data? So we compare 4 types of code models. Code model, which is trained on web based code data. Then we have code markup. In this, 20% is the markup language here is HTML. Then we have code adjacent, which is in this 15% is code adjacent data such as your GitHub issues, Stack Exchange, Jupyter Notebook. Then lastly we have code synthetic data. In this, 10% is synthetically generated code. For different tasks such as natural language reasoning, world knowledge, to code generation, code synthetic gives the best performance. Code in pre-training cool down. In this paper, we evaluate the impact of including the code in cooldown, comparing 3 models: pre-train before cooldown without code data, cooldown with 20% code data. And we find cooldown with code data is the most beneficial. So the results for the natural language reasoning task, adding 25% code data boosted the natural reasoning by 8.2%. So the best word, the balanced model is comparatively best if we are going to go with natural language reasoning task. For world knowledge task, code and pre-train provide a 10.1% boost in world knowledge task. So cooldown with code was a very crucial in world knowledge task. Then for code performance, code heavy model outperformed text model by 12 times in all the code tasks. So what balanced model gave a strong performance but lagged in if we compare to your code only models. So the best recipe for code performance, for code benchmarks, code only models were the clear winner, and balanced text models were strong performance in natural language reasoning but lagged heavily in code. Then synthetic code data was a key differentiator in boosting the code overall performance. So the key recommendation for pre-training with code would be including a balanced mix of code and text data from the start, and using synthetic code data to improve both the code as well as your natural language task, and prioritizing the inclusion of code in cooldown phase to maximize the performance gain. So the future research area could be how we can see if we scale the synthetic code generation. Right now we are only seeing it to up to 20%. What if we increase it? And we can also explore as new models are being released with different training model. What if we are doing any task specific tuning, and we can always introduce advanced cooldown phases. So the final takeaways from my side would be code data significantly improves AI model across all data, not just if we are talking about code specific data, such as your very common example would be ChatGPT. So ChatGPT is heavily used by programmers also as well as your general audience also, but it was not intended to support your code related tasks. It was a general model to be used by the general public. But if we see, and not just ChatGPT, any other model which has been released for your general purpose task, it includes some amount of code data in its training data. So balanced model with both text and code are best for general task, while code heavy models dominate the coding benchmark. So if you want to go for a task which require heavy codings, let's say you want in a specific area and you want in your coding related only, let's say you want to create a software engineer or automate any development pipelines, then my recommendation would be to go with code heavy related models which are released for these purposes only. And the cooldown phase, particularly with code, is critical for optimal model performance. That's it from my side. Thank you, everyone.